Before we get into this, it's been a while since we've seen each other and talked about math. The unit we're in systems of equations. What is a system of equations? Yeah, two lines, right? Two lines, and they're crossing each other. That's what we're looking for. So anytime you have more than one line, the reality is we only deal with two lines. But you could have like 3, 4, 5, 6 different lines, and it would still be called a system of equations. Okay? A system of equations is more than one line being considered at the same time. Solving a system of equations is where they cross each other. To figure out where two lines or two equations cross each other, we learned 3 different methods. It's really up to you to choose which method you want to use. Right? There's times when some are better than others, and I'll show you kind of some examples of like, oh, this is when I would do this is when I would do this, so on and so forth. But the 3 ways we learned, the first one was graph. The trick to graphing was to make sure that both equations were y equals and y equals. You then put them in your calculator as y1, y2. That was the trick to graphing. Remember, in your calculator, you then went second, it's been a while, trace, and then the 5th option, which is intersect, right? It's where 2 lines cross each other. Awesome. It's been a while since we've done that, but it's what most people prefer to do. The second type we learned was substitution. Substitution is my personal favorite, and I think the one that you probably see the most of going forward in math. So substitution is where you get one letter by itself. So for instance, you could have x equals and then a whole bunch of stuff. And you substitute that into the second equation. And we did that like big loop of substituting, right? And we came up with 2 answers. The third way you learned without me was elimination. Okay, so that was on Thursday. We're going to go with Thursday. Mr. Farkash was here, right? Yes. When he did elimination, did he always just set it up the same, or did it matter? Like, some teachers have different preferences. So for me, I just say as long as they follow the same pattern. So like this, 2x plus y equals 10. If I have a pattern like that where it goes like x's and then y's and then equaling and then a number, I want my other equation to also be in that pattern. So we got like 3x minus 4y equals 9. Something like that. Is that what his setup for you guys was? Yeah, it's like the same. Oh, perfect. Whenever you have something that looks like that, which works pretty good for word problems usually, that's when you want to do elimination. It follows like a nice little pattern. The idea is that you add or subtract the 2 things together and eliminate one of the letters. Right? So if I subtracted these 2 equations, hopefully I had like 2x and 2x, and then they cross each other out. I think we'll probably just force our way to solve one way of each so we can see it. But if you need practice, there's tons of it in there on your practice booklets, as well as the assignment I'm about to give you guys today, which will have practice in it too. Awesome. Problem solving. There's step-by-step instructions for problem solving. I don't think it's very... You can't really do step-by-step for problem solving. Sometimes you just got to think about what's going on. Right? Like I have a process, which I'll walk you through my process, but everyone's going to have their own little strategies and their own little techniques that help them out, right? And their own little way of critically thinking about things. This first type of question, we call it like a number problem. That's what I do. They just talk about numbers. There's nothing really relating them. It's not like apples and watermelons and crazy like that. It's just numbers being given to you. To build these, you have to somehow create equations out of the sentences. Each sentence is going to be a different equation. So if you look, this first sentence is going to be one equation. This second sentence is going to be our second equation. And that's how these questions will typically work. Each sentence is an equation. Building these types of questions, if you tried to look at the whole thing and tackle it all at once, it's really challenging. If you break it down word by word and you build it as you read it slowly, it's not so bad. So I'll show you what I mean. If I read the whole question, the difference between two numbers is 9. The larger number is 3 more than twice the smaller number. Find the numbers. Right? Confusing. Hard. Very challenging. I have no idea. If I read it again, but go really slow, and every time I read something mathematical, I build the equation, it's not so bad. So let's read this out. The difference. What does the word difference mean in math? Subtraction. It means subtraction. So I know that my purple equation is going to have a subtraction sign. The difference between two numbers. Do we know what these two numbers are? Not yet, right? We don't know what they are. So when you don't know something in math, what do you call it? X and Y. Perfect. This is the difference between two numbers. I have no idea what those numbers are, but that's the difference between them. Awesome. The word that is very important in most of these sentences is the word is. Is means equal sign. So the difference between two numbers is 9. There we go. That's the first equation. Not so bad if you go really slow and build it word by word. Sentence 2. The larger number. Okay, over here. We didn't know either of these numbers. We had X and Y, but we do know which one of them is larger. Logically speaking, if Y was the larger number, you would have had a small number minus a big number. It would have equaled a negative number, right? That means, looking at this, since we equal 9, the larger number must be X. For instance, 10 and 1 would work. Just for fun, 2 random numbers. But this one always has to be larger because it's equaling a positive number. It might be really wise, once you kind of figure that out, to write that to yourself. So like, X is large. And Y is the small. And they don't always do larger, smaller. Sometimes they just say the first number, the second number. And it might just be wise to keep it in order and say, oh, X is my first number, Y is my second number. So that you're always building it the same way. Awesome. The larger number, that's X. Is means equal sign. This mathematically means the larger number is 3 more. How do you represent 3 more in math? Somebody whisper. 3 more would be 3 plus. And think about it. If you have 10 apples and you get 3 more apples, you're just adding 3 apples to your pile, right? That's all it is. The larger number is 3 more than twice the smaller number. Twice means multiplication. The smaller number is y. 2y. That's my second equation. The larger number is 3 more than twice the smaller. If you go word by word by word, it's not that bad. Next year, as you go into Math 20-1, 20-2 does a little bit of it as well. You do the same thing, but just bigger. It just gets a little bit more complex. The sentences get a little longer. That's it. But the same strategy will still apply. Read it slowly, build it slowly. Someone like me who is very good at math and I've done a lot of questions like this, I can't do that without doing this. I have to, and I have to go slow. So even if it was me by myself, that's how I would do this question. There's no tricks to it. Now that you have two equations, it says find the numbers. You're trying to find where these two systems have the same numbers that would work for both of them. That's where two lines cross. It's solving a system of equations. It does not say how you have to solve it. We have three methods. Graphing is really good if you have y equals and y equals. Looking at this, neither of these are y equals. So I'm not really interested in graphing. Elimination is really good if the things follow the same pattern. This one goes x's, then y's, then equals a constant. This one goes a letter, so x's, equals a constant plus the y's. Not the same order. Substitution is really good if one of your equations has one of the letters all by itself. Looking at this question, substitution is prime because of this guy right here. Right? X is already by itself. That means I can take this and substitute it in to the other equation. It was already really easily set up for substitution. Reality is, you could have done the other methods too. It would just take some legwork to get there. Right? You'd have to do a little bit of algebra to move things around. But the other methods would work. I'm going to substitution because that's the most efficient way through this question. A reminder of substitution. You take your letter that was all by itself. You substitute it into the other equation. When you substitute into the other equation, you change the letter x to be 3 plus 2y. And you put it in brackets like that in case there's any multiplication that you have to do. Everything else in this purple equation remains the same. So I'm trying to color code it so you can kind of see what changed and what stayed the same in that purple equation. After we substitute, we expand. There's no expanding needed here. There's nothing to multiply. If there was a number right here, that's what I would expand in. But there was no number there. So there is no expanding. That means we can just rewrite the same equation without the brackets. For you guys, reality is you just erase your brackets. And I can't quite do that as nicely. So that means I can literally just skip to this next step, which is what it would look like after I expand. My next step after expanding, which I didn't really do, is collecting like terms. If there's anything that can be added or subtracted together, do so. If we look, y's go with y's. That means those can combine, everything else stays the same. So my 3 is still here. Plus 2y minus 1y equals plus 1y. Equals 9. After I've collected my like terms, I should now have a linear equation, meaning I have only one letter left, and it's already combined with everything else. Like everything's simplified at this point. To solve a linear equation, you need to get the letter all by itself. Move every number the other way. In our case, we have a 3 next to that y. We need to get rid of that 3 by subtracting 3. What you do to one side, you do to the other. That means my answer is y equals 6. Just over here. Keep it as That's your first number, and we know it's our smallest number. To get the other number when using substitution, you then go back to this equation, and you're going to change y to be 6. That gives you x equals 3 plus 2 times 6.
Couldn't you just times 6 by 2 for that?
Definitely, yeah. And if you, like, for some of these, like, some people might have been like 6, 9 more, 15. Right? And they might just be able to do it. That's fine too. So even if you can see that and you just know how to do it, 100% you can just do it. With some of the more complex ones, you'll probably want to calculate it. It just depends on the level of the question. Once you've done this substitution, all you need to do is put this in your calculator. And that will tell you what x equals. In our case, x equals 15. That means my two numbers are 6 and 15. I really like that question, or those types of questions, mainly because the greatest movie ever made is Mean Girls, and Mean Girls does that in their Math Olympic questions, just for the record. Awesome. Not too bad. Not too bad. It's easy when I guide you. You definitely want to practice that. All right. Perimeter questions. These questions also will continue on in math for like the next couple of years. And again, they do just get harder and harder. Ours follow kind of a basic model. And we almost always have a rectangle. Sometimes they give us a different shape, but almost always a rectangle. And they usually keep it pretty simple, pretty straightforward. They don't add in anything crazy like fences or lakes or something like that, which is what will happen next year, where you'll have like perimeter questions like that, except applied to a different situation. So like the perimeter of a fence around a yard, right? And then there's certain things in the way of your fence, whatnot. For us, when we do perimeter questions, we need to remember what perimeter means. Pretty important. Perimeter is the distance around the outside of something. Right? So if we did perimeter around this room, I would measure all the walls, like all the way around the room. For us, this question is saying the perimeter of a rectangle is 40 meters centimeters. 40 meters, 40 centimeters. What that means is that if you took a rectangle and you added all its sides, it would equal 40. Do we know what those sides are? No, right? That's the question, right? If you keep reading, it says find the dimensions. We don't know what the sides are. But we do know something about those sides. We know that these two sides are the same length. We don't know what that length is, but we know it's the same. So we're going to say that's x and x. We also know on a rectangle that these two sides are the same. They're different than x, but they're the same. So we're going to go with y and y. This idea allows us to build our perimeter formula. If I was to tell you how to calculate the perimeter of this rectangle, what you would do is you would go x plus y plus x plus y. And that should equal 40. A simpler way of saying that is that perimeter is 2 x's plus 2 y's. When they tell you perimeter, they tell you that formula. If you want to put lengths and widths, you're more than welcome if that makes more sense in your mind. I'm just putting x's and y's because it fits my diagram. And we usually use x's and y's. When you see perimeter, build that formula. Awesome. The second sentence typically gives us our second equation. The second sentence says the width is 4 meters less than the length. Okay, we're going to say that y is my width and x is my length. If you want to write that down somewhere, also smart. I'm going to say this is length width. width is 4 meters less than the length. You can build that equation the same way we built our last equation, building it as you read it. Width was y, is means equal sign. Width is 4 less than the length. If you're doing less, if I say you got 10 apples, now you have 4 less, you are subtracting. So 4 less than the length means you go length minus 4. That means the width is 4 less than the length. That sentence people usually reverse. They usually end up building that as y minus 4 equals x, and they actually have their width and their length reversed, like backwards. When you're doing this, that means if I chose a length, let's say my length is 10. 10 minus 4 would give me my width. My width would be 6, which is 4 less than the length. Right? That's how that works. So build it the way you read it. Awesome. You can choose any method you want to solve that. What's the most efficient way to solve that? Would graphing be efficient? No, it's doable. It's not actually that bad if you wanted to graph this one. There's a little bit of work you got to put in on the left side. Right? The purple equation is not in y equals. Therefore, the purple equation is not nicely set up for graphing. Is this equation set up for elimination? Not quite. Close, but not quite. We want the same pattern, or the same sequence of things for it to be set up for elimination. This one goes number equal x, y. This one goes y equal x number. So we'd have to move things a little bit for it to be a nice elimination question. Elimination also needs the same number of x's or same number of y's. If you look, this one has 2 x's, this one has 1 x, this one has 2 y's, this one has 1 y, so it's a little bit different. We want the same for elimination. Substitution, however, is beautifully set up. The reason being, one of your letters in one of your equations is completely by itself. The second equation has y completely by itself. Therefore, I can substitute right off the bat. I'm going to give you about a minute or two to see how far into the substitution process you can get. Maybe you can solve it, maybe you get stuck. Right? But try your absolute best. I'll give you a couple minutes. When you do your substitution, I'm going to do it in a different color so it stands out. The way you can make your substitution stand out is by putting your brackets around it, right? But brackets are really important to us. So we have 40 equals 2x plus 2. And then instead of y, we're going bracket x minus 4. The brackets help you remind yourself, like, oh yeah, that's a package, it's together. I substitute this whole thing in, and that means I need to multiply if there's any sort of multiplication here, in which case there definitely is, right? The first step after substituting is expanding. When you expand, you get 40 equals 2x plus 2x minus 8. Right? Remember, expanding is multiplying into the brackets. After you multiply into the brackets, you're then allowed to add and subtract like terms. Like terms means that if they have the same letter, same exponent. In our case, our like terms are right here. We have 2x and 2x. They're the same letter, same exponent. I would combine these like terms to be 40 equals 4x. And the 8 is not a like term, so it's on that back side. We still have a bunch of people who are, you're adding too many things together, right? You're trying to combine all of these things, when in reality, only like terms go together. If something can't go, just leave it on the side. Just keep writing it out, and you're fine. Awesome. After you've collected your like terms, you should have a linear equation, meaning one letter all by itself, right? Just x, there's no other letters. We now want to get it alone. To get it alone, we move the other numbers away from it to the other side of the equal sign. The first thing we always move is additions or subtractions. I need to move the subtract 8 as my first thing. To move a subtract 8, I do the opposite, I add 8. That gives me 48 equals 4x. After I've moved my additions and subtractions, I move my multiplications and divisions. I have a 4 times x. To move times, you divide. So I divide both sides by 4. That gives me 12 equals x. My length of my rectangle is 12. For some of you, you might then just be able to go and figure out the width right away in your head. Awesome. Do that on these questions. It definitely works. The mathematical thing to do is to then take that answer and put it into the other equation. So change x to be 12. That would give me y equals 12 minus 4. That means y equals 8. My dimensions to my rectangle, or my two sides, my length and my width, are 8 and 12. The way they can make this a little bit more complex is then they can like add something onto it. So instead of saying find the dimensions, they could have said calculate the area. And the only way to calculate the area would be to find the dimensions first, right? Then go length times width, and that would tell you your area. So they can make the questions a little bit more complex by doing something like that. Or saying something like, if they wanted to add 2 to each side, what are the new dimensions? Okay, my new dimensions would be the old dimensions, which I now have defined, plus 2. Okay, but they just make it a little bit more complex. With these perimeter questions, this will always be the first thing you have to do, is calculate the width and the length. Then do whatever else it's asking. But that's always the first step. Awesome. Money questions. Money questions are my favorite because I think they're actually kind of applicable. Again, they'll get more complex in the future. We'll start off with Gary, and then we go into an investment question. Drop my marker. So, reading the money questions. You're going to get 2 equations, right? This is the system of equations. Usually, each sentence is an equation. We'll see if that works out again for us. This says, Gary had a total of $260 in $5 bills and $10 bills. If he has 33 bills in total, how much of each denomination, that means how many of each bill, does he have? Awesome. Let's start with the first sentence. It's going to give us our first equation. Gary had a total of $260 in 5 and 10. How many $5 bills does he have? We don't know. When you don't know, you make a letter. So I'm going to say x equals the number of 5s. Not how much it's worth, but the number of them. Right? He's got a stack of $5 bills. X is how many there are. How many $10 bills does he have? We don't know. When you don't know, you say y equals. first sentence, we can make an equation. So if you were to calculate how much money you have, right, we'll do loonies and toonies because people are better with that. And I said, all right, you got $10 in loonies and toonies. And you were to count that out, and you're like, okay, well, I have 3 loonies. Why? I picked a number that's not doable. I have 4 loonies, right? And I have 3 toonies. If you had to figure out how much money you'd have, you'd be like, well, 3 toonies, 3 times 2 is $6. Plus 4 loonies, 4 times 1 is $4. I have a total of $10. Right? You do each thing multiplied, add it together. That's what we're going to do here. Gary has $260. If he was to count his money or figure out his total, he would take how much each thing is worth and times by how many he had. So for us, it would be 5 times X. That represents how much money he has in $5 bills. Each one of those is worth $5. Plus, he has 10 times Y. That's how much each $10 bill is worth. Times it by 10, that would tell you how much you have in tens. That's your first equation. Tricky. The second equation is even trickier. People usually do a good job building this one. It's this equation that they struggle with. If he has 33 bills in total, people have a hard time turning that into an equation. If you had X 5s and Y 10s, and you had to figure out how many total you had, you would just go X plus Y. And that would tell you how many you have. Gary has 30. There's your 2 equations. All right. Now that you've built your 2 equations, which that's always our strategy for our word problem, right? Each sentence creates an equation. We now have to solve our equation. You have to pick the best strategy. Yep. You don't have to. You should try to. Right? Try to pick the best strategy. The thing with it is if you're really good at one of the strategies and really bad at the other strategy, then just keep doing the one you're bad at. Right? That makes sense. This question is very well set up for elimination. The reason being is it follows the same pattern. A number equals some x's plus some y's. It follows the same sequence. That's a good sign for elimination. Reality is, if you're really good at substitution and you're awful at elimination, unless it tells you how to solve it, you could always try the method you prefer. And this one isn't too bad to get into substitution, so it is definitely doable. I'm going to go through elimination with you because that's the optimal way to do this question. Plus, we haven't done an elimination question yet. So, to do elimination, first thing is make sure it's in the same order. We've already done that. It's in the same order. Number equals x's, y's. Awesome. The second thing is to choose which letter you want to eliminate. That means make the same. For me, I'm going to try to eliminate my x's. Mainly because me and my x's have some issues. But also because the number is smaller. So I'm going to eliminate my x's in this question. Nothing. I got like 1 small. Thanks. Appreciate it. Okay, so I'm going to try to eliminate my x's. To eliminate your x's, you have to have the same number in both equations. If you look, this one's 5x, this one's 1x. The way we make them the same is by multiplication. What can I multiply the blue equation by to have the same number of x's as the purple equation? By 5, right? It's pretty nicely set up. So what you do is you come to this blue equation and you times everything by 5. And what you do to one side, you do to the other, so I'm doing it to everything. This now gives me a new equation. It gives me 115. Somebody do that. I just get in the mod. What was 115? Equals 5x plus 5y. And I'm now going to write the equations one on top of the other one like that.
It's 160.
I wasn't even close. I'll call Mr. Farcash, get him in here. He doesn't make mistakes like that. 165, thank you. And then I write them one on top of each other, like we got right there. Alright, the reason why we wanted one of the letters the same, and the reason why we write them one on top of each other, is because now we're going to either add or subtract these things. On Thursday, did you guys do both? Like you did addition and you did subtraction, or did he always do subtraction?
We did both.
Both? Wonderful. That's how I like it. There's definitely like a theory that you should only do subtraction, and then people always set up their questions to be subtraction. I prefer if you know what's happening and do the one that fits. Okay? It's good for your thinking process, I believe. To choose whether you're going to add or subtract, you look at the equations that are the same. By equations, I mean the letters that are the same. These are the letters that are the same, right? My x's. If you wanted to eliminate them, if they're the same symbol, they're both positive, then you're going to choose to subtract. If they were opposite symbols, one of them was positive, one of them was negative, I would have added. Okay, that's how you can decide. But for me, I do subtract because I know 5x minus 5x will eliminate that letter. It'll be gone. So I'm going to subtract these two equations. Yep, for sure. When you subtract, you just go straight up and down. 260 minus 165 is 95. Equals is still there. People tend to lose that equal sign. You need to make sure it's in the same spot. 5x minus 5x eliminates. It's gone. 10y minus 5y is 5y. You've successfully eliminated if one of the letters is now completely gone. If you eliminate and you still have two letters, you've made a mistake. Right? Awesome. The good thing about elimination is you're usually only one step away from solving, maybe 2 steps away. And by solving, I mean getting the letter completely by itself. We're going to divide both sides by 5. When we do that, that will give me my answer of 19. 19 equals 1. The confidence is shaken. Y represented the number of $10 bills he has. He has 19 $10 bills. You could then figure out how many $5 bills he had, whatever method you want. So if you can do it in your head, fantastic. If you want to like count it out money-wise, sure, do it that way. Mathematically, the way we figure it out is we take our answer and we substitute it back into one of the equations. I'm going to substitute it into this guy right here. So that I now have 33 equals x plus 19. So even in elimination, I finish off with substitution. The ending steps are the same. I need to get 33, sorry, I need to get x by itself, so I'm minus 19 from both sides. I now have 14 equals x. And he's at 14 $5 bills. And these questions love to say, like, how many $5 bills does he have? And so you have to know which one you actually solved. That's why this little side piece up here helps, like writing down which one's which. How's elimination feel? Okay, yeah. What do people prefer? Do people like, let's just do just substitution versus elimination. So no graphing, because too many people usually like that. How many people prefer substitution? How about elimination? About half and half. And then a few people who didn't vote, either too confused or indifferent, one or the other. That's not bad. Usually the split's really heavy on the elimination side. People love elimination. I'm way better at substitution. That's why I like substitution. And it's more logical to me. Like this whole subtracting of equations has never fit in my brain. I always like substitution. It makes sense to me. That's why I go with that. But go with what you're best at when you can. Yeah, for sure. All right, we got one more question that we'll do. It's another money question. It's a little bit extreme. It's a little bit over the top, challenging, I think, to set up. But we'll do it together and see how it goes. So it says Laura invested her inheritance. Inheritance is what you get from somebody who passed away. So when my grandma passed away, she left her money or her inheritance to my mom. So that's what Lori did. She got an inheritance. Laura invested her inheritance of $48,000 into two different mutual funds. Mutual funds are things that help you make money, right? So it's like somebody takes your money and invests it in a company, makes money on that company, gives you back the money. That's a mutual fund. At the end of 1 year, she had earned 10.5% interest, and the other fund had earned 12% interest. Both of those are very good gains in life. If she received a total of $5,520 in interest, how much did she invest in each mutual fund? It's like, holy smokes, right? This question's a little extreme, a little over the top. The first thing we're going to do is figure out what our X and Y are for this question. The question asks, how much did she invest in each mutual fund? That might help you guide what your X and Y are. X is the money in your first fund. Y is the money in the second fund. And she took her money and put it in two different accounts. How much did she put in each account? That's the question. That means that's what my X and Y are. Beautiful. We're going to try to build these two equations. The first sentence builds the first equation. It says, Laura invested her inheritance $48,000 in two different mutual funds. That means if you took the amount of money in X and the amount of money in Y, it would equal her total amount of money she had. So 48,000 equals X plus Y. First sentence built the first equation. The second equation is actually going to come from the second and third sentence. And it's a little more complex. So it says, at the end of 1 year, one fund had earned 10.5% interest and the other had earned 12% interest. If she received a total of $5,520 in interest, how much is each thing? I'll show you mathematically what it looks like, then I'll explain why it looks like. Okay. So we're going to take the total amount of interest she made, $5,520. And the way we would calculate that is you would take the percentage she made in each fund and times it by that fund amount. So for instance, she made 10.5% just in the first fund. 10.5 is 0.105. If you're not sure, you divide by 100. Okay, so to turn percentages into decimals, you divide by 100. I want to make a note on that to yourself. That gives you your percentage as a decimal. You take that number and you times it by how much you had in that fund. So for us, it's 0.105 times X. This is the amount of interest she made in her first account. You're going to do the second equation as well and add the two total. So The second one was 12%. So plus 12% is a decimal is 0.12. I get that. Computer's slowing down. I get that by dividing by 100. And then times it by 1. That's my second equation. Wicked. Solving this. It's an ugly one to solve. The reason it's ugly to solve is because of these decimals. No matter what method we choose, the decimals are definitely going to cause a pain for us. How I'm going to solve this one is substitution. Even though elimination is probably more efficient, I'm going to go with substitution. My reason being, if I want to do elimination, I'm going to have a heck of a time getting numbers that are the same. And getting my x's to be the same amount of x's and my y's to be the same amount of y's. I'm probably going to have to deal with decimals. I don't like decimals. So I would much rather just keep things whole and do substitution. But it's definitely your choice. If I had a more complex question like this for substitution, the first step is pick an equation and get a letter by itself. I'm going to pick the purple equation, and I'm going to get y by itself. To do that, I subtract x from both sides, so that I now have 48,000 minus x equals y. And I can take that and I can substitute it into my other equation. And it's not going to be pretty, but we're going to be able to do it. That gives me 5,520 equals 0.105x plus 0.12 instead of y, you're now substituting in 48,000 minus x. So like I said, even though it's not a nice substitution question, we can guide it and turn it into one. After we substitute, what do we do? First step after substitution is expanding. You need to multiply that decimal into the brackets. When you multiply that decimal into the brackets, I'm going to need a calculator for that one. I'm going to end up with my 0.12 times table memorized. You're going to end up with 5,520 equals 0.105x. You go 0.12 times 48,000, and you get plus 5,760. You've also had to multiply the 0.12 times your x. When you do that, there is a number in front of the x that you would multiply by. What's that invisible number in front of the x? Okay, it's a 1. So that means you're going 0.12 times 1. It gives you negative 0.12. First step was expand. After I expand, I collect like terms. My like terms are my x's in this case. I have 0.105x and then minus 0.12x. Use your calculator. Make your life easier. Right? So we'll go 0.105 minus 0.12. And you now have 5,520 equals negative 0.015x. When I added those together, that's what I got. 0.015x, and it's negative. plus 5,760. I expanded, I collected like terms. Now I try to get my one letter by itself. To get the one letter by itself, I'm going to subtract the 5,760 from both sides. 5520 minus 5760. You get negative 240 equals negative 0.015 x. My last step is to get rid of that 0.015. Remember, that's multiplied together because there's no symbol between the x and the number. To get rid of multiplication, we divide. So you're going to divide both sides by negative 0.015. You get an answer of $16,000 is X. X to us was the amount of money in the first fund. So we have $16,000 in the first fund. To figure how much is in the other fund, you could logically try to figure out, or you could substitute it in here and figure it out. So for our second fund, we go 48,000. Oh, you got this. Minus 16,000. And that will tell you what's in the other fund. When you do that subtraction, you get 22,000, 32,000, 32. There's 32,000. The amount of money in the first fund was $16,000. The amount of money in the second fund was $32,000. That answer makes sense because that's a total of $48,000 if I was to add those together. And you can always check your answer. You could verify your work by taking your solution and putting it in the equations and seeing if both sides equal. Remember, that's called verify. Awesome.